Hey, this is part 2 of the review, chapter 9. We're on number 4, multiple choice. Number 4, we have a collision. And most of the time when we have collisions, this one's in 2 dimensions, so it's going to involve vectors. Usually we would hop right into conservation of momentum, which we could do. There's a way to eliminate a couple of choices fairly quickly, and that's the word elastically here. Elastic collision means that the kinetic energy total before, which is just the kinetic energy possessed by this ball, is equal to the total kinetic energy after the collision. Prime indicates after the collision. So the total energy, or total kinetic energy before, is just 1/2. Now we don't know the mass, but these two balls are identical. So I'm just going to give them one mass unit of kilogram. And so beforehand, 1/2 times 1 times 10 squared ends up being 50 joules if we assume 1 kilogram, which I'm going to do. We also could alternatively keep the m in and watch them drop out, but in this case I think it's probably easier just to put in a kilogram. So that's 50 joules of kinetic energy before. So that's kinetic energy total before. And since it's elastic, now only if it's elastic is this true, the kinetic energy total afterwards is also 50 joules. So the kinetic energy of this ball x prime is 1/2 times 1, it's the same mass, times v squared, which is 36. 6 squared, 36. So half of that, that's 18 joules. So what that means is my kinetic energy of the y then must, in order to equal 50 joules, in order for kinetic energy to be conserved in this elastic collision, has to be 32 joules. So kinetic energy of ball y, this is kind of confusing because they have x and y, and we're going to be looking at x components and y components in this. So what that means is we know that ball y has to have 32 joules of kinetic energy. Well, A is out. Something happened to my choices here. I think this was A, this was B, this was C, this was D, this was E. So this one's out. Choice B had the ball going at 10 meters per second, which is not possible because we would have too much kinetic energy. At 4 meters per second, we'd have 1/2 times 1 times 4 squared. 16 times 1/2 is 8. That's 8 joules. With the 18 joules, that means our total energy would not add up to 50 joules. And so we know the ball has got to be going either 8 meters per second at 37 degrees or 8 meters per second at 53 degrees. To eliminate choice D or E, we look at conservation of momentum, and that is momentum total initial equals momentum total afterwards. And for this we have we're given 2 different angles, and the way I would probably solve this is to take a look at the y component of this vector. Now the y component of this, the momentum here, is sine of 53 times 6, and this is one case where your yellow sheets are helpful, because on those, which are allowed on the multiple choice section, we find that the sine of 53 is one of the ones given, and it's 4/5. So this is 24/5, and that's this y component here. So which one of these has a y component of 24/5? And that's the answer. Why? Because if you look at the beginning, there is no y component. The total momentum, and we have to look at the total momentum in both the x and the y. The total momentum in the x is 10. 1 kilogram times 10 meters per second, so it's 10 kilogram meters per second. Again, we're assuming a 1 kilogram object. The total momentum in the y is 0. That means afterwards your total momentum has to be equal to 10 in the x. There cannot be any y component. momentum is a vector quantity. So the total momentum after has to match the total momentum before, both by magnitude and direction. So we can either look at which one of these has the right x component or which one of these has the right y component. And I think y might be a little bit easier because the x we have to add the results of x, the x component of the x ball. Here, all we have to do is match which one is 24/5. Whichever one is 24/5 down wins. So start with D. I don't know if it's right, but the y component would be sine of 37 times 8. And sine of 37 times 8 is, now you look up in the tables, that's 3/5. So that's 3/5, that's 24/5. We have a winner. Okay, so D is it. Now, I would not do this if I was taking a test because you're only given 80 seconds. In fact, I probably wouldn't even do the kinetic energy part. I just did that to illustrate, to teach something about elastic collisions. And one is that elastic collisions means kinetic energy initial total equals kinetic energy final. The other thing is kinetic energy is not a vector quantity. So notice when I did kinetic energy, I didn't care about the directions. I only involved directions when we talked about the vector quantity momentum. So onto this. I probably wouldn't do this, but let's just disprove this is not the correct y component. This would be sine of 53 times 8. Well, it can't be the same. I mean, it's a different angle. But sine of 53 is 4/5, so 4/5 times 8 is 32/5. So this one has the wrong y component. Choice E would mean that the total momentum of the object afterwards has a downward component, because 32/5 is larger than 24/5 up here. So the correct answer is, if I have these A, B, C, D's right, the correct answer is choice D. And if I don't have these right, the correct answer is this one right here. The last two questions are paired, and for these we have a puck moving into another puck. They have different masses, different speeds, different directions. They're going to collide. Take question 5 first. What is the total kinetic energy of the system? What is kinetic energy? 1/2 mv squared. Is it a vector? No. So we just add the scalars. So this one, and you want to do this kind of stuff reasonably quick, but without making a mistake. 2 squared is 4. 2. This is 3 units of kinetic energy. So the kinetic energy of this one is 3. If I look at the kinetic energy of this one, this is 1/2 times 4 times 1 squared. 1 squared is 1 times 4 times 2, that's 2. 2 joules of kinetic energy here, 3 joules here. So my total is 5 joules, which is one of the choices, choice B. And now we want the total magnitude of the momentum. So magnitude means we don't care about direction, but you definitely care about direction when you're solving this, because we have 4 units of momentum from the one heading up the page. The one heading to the right has 1.5 times 2. 3 units of momentum this way. So the total momentum, now it talks about the total momentum after what we want, but that's simply equal to the total momentum before. This is a law of nature. It's observed. The momentum in collisions is conserved. So the momentum before is 3 units this way plus 4 units this way, and we have our little 3, 4, 5. Thank you, AP. And this is our answer, 5 kilogram meters per second. 3 squared plus 4 squared is 5 squared. I would imagine that the most common answer that is incorrect is 7, because people not treating this like a vector quantity quickly say 3 plus 4 is 7. You guys won't make that mistake. So that concludes the answers to this multiple choice section. I'm going to try to put up as many of the problems as I can. Britain out for now.